Welcome back, Tenfolders. Welcome back to an epic edition of Tenfold Live, where we are looking at the errors and misconceptions of the matrix in paper 2 to help you not to make the same mistakes on a show that is proudly brought to you with lots of love by Liberty. A very special shout out always goes out to the people that are not only sponsoring this program, but they're also behind our awesome app, which is called the Tenfold Education app. If you don't have it, do make sure that you grab yourself this very useful app. It's available on your app store for anybody doing math or sciences, grade 10, 11, or 12. This is actually going to be one of the very useful tools to have. On YouTube, we are also available. We've uploaded lots of videos. We are Mindset Land. Do make sure that you go there, find us, and subscribe to the channel. We've got a lot of very useful videos that you can find and use if you are interested in any section that you might find challenging. I promise you we have some work we've done on that, so do make sure that you go there on YouTube and find us and you subscribe to that and like all the videos that we have uploaded. I promise you they will very much assist you to prepare yourself for the upcoming end of year exams. On today's program, like I said, we are looking at the errors and misconceptions that you are likely to make to help you not to make the same mistakes. So I'm going to go to the last part, which is the Euclidean Geometry part. What are the errors and mistakes that you're likely to make when you're doing Euclidean Geometry? Without any waste of time, let's jump right into it. All right. So this is going to be part 4, Euclidean Geometry. And I think just quickly, it's important for us to understand that in geometry, you are likely to get questions that are talking about theorems and axioms of lines, theorems and axioms of triangles, theorems and axioms of circles, which will touch on circles and angles, center and angles, cyclic quadrilaterals, as well as tangents. There's also similarity, the concept of proportionality, and then lastly, maybe you might find the theorem of Pythagoras very useful. It actually touches very closely to what we speak about when you're talking about similarity. So even if you don't know it, you are able to survive these questions, but if you know it, it helps you to work out some solutions really quickly. Okay, so when we are looking at Euclidean geometry, which is where we are dealing with trying to find values of angles in terms of other angles, well, what are the challenges or the errors that we likely see? What are the misconceptions that we see from the kids? So number one, for all these things that we have in geometry, this is the very first problem that we have. We have the problem of kids not reading the love letter, okay? This is actually an error, not reading the love letter thoroughly, okay? Not reading, let's say, the love letter, okay, the opening statement, the love letter thoroughly. Okay, not reading the love letter is the number one problem. You guys have to always make sure that you read the love letter, you highlight keywords, and you update the diagram as you go along. What is written in that opening statement? What is the examiner saying to you? Why would anybody say there are two parallel lines? There's a reason why somebody says to you, line AB is parallel to line PQ. We don't put things for fun. There's a reason why we say that, okay? If you're doing analytical geometry and somebody says to you, line AB is parallel to line PQ, in your brain immediately you're thinking parallel lines equal gradients. But you're doing geometry. If you're doing geometry and somebody says two lines are parallel, in your mind immediately you're thinking fun theorems, okay? Corresponding alternate co-interior. Those theorems might work. In fact, not that they might work. One of them is definitely going to work to help you figure out the solutions. So when we put the love letter, that opening statement that you get is very important for you to make sure that you read it thoroughly. You highlight keywords, tangent. What does it mean? Center. What does it mean? Some line is a diameter. What is it? All those words are keywords. They imply something. They mean something. When we mention them in the opening statement, you have to always make sure that you take them serious and you make notes. You highlight what those could mean to you. If you don't read them, I promise you, you might run into challenges as you're trying to solve the problem. So that's the number one problem that I want you not to make a mistake on. So please always make sure you read the love letter against the diagram. And as you're reading, you update the diagram. And also, as you find solutions to the other questions, anything that you've calculated, go back to the drawing and update the drawing, right? You found angle B, write the value of it. You found angle X, find the value of it, write it on the diagram, because as you go along, the diagram gets richer and richer, it gets more and more useful. It allows you to solve more and more questions as you go along into the follow-up questions. All right. Now that's the first problem. Now moving on to the second problem, let's try and think about what else you guys always have a problem with. Is not updating the diagram. We've already discussed it. Now the other number one problem is you guys assuming stuff. Okay, assuming stuff. You cannot assume stuff. If you're looking at a diagram and you look like there is a tangent, it looks like there's a tangent. If nobody says there's a tangent, don't assume. You cannot assume that there's a tangent. So you can't assume this. Let me put a list here. I'm going to put a list here of things that you can't do. You cannot, grade 12s, assume the following. Just because it looks like it is, then it's not. If it's not, it's not. If nobody says it is, then it's not. You can't assume that there's a center. If it looks like a center and nobody says it's a center, do not assume it. You cannot assume a tangent. If it looks like it's a line that is touching the circle once outside, if they don't mention explicitly that it's a tangent, don't assume it. If it looks like it's a diameter, don't assume it. If they don't tell you, they have to tell you. If something looks like it's a 90-degree angle, don't assume it is. If somebody tells you that the diagram and you look at it and you look like, or you feel like there's two parallel lines, if they don't say that, do not assume that they are. They need to tell you. Okay, and in an exterior angle, you have to be told that some line is straight. If they don't tell you that a line is straight, then you can't make those assumptions. Grade 12s, you cannot make those assumptions. Now, if I say, for example, to you that I've got a diagram here, and this is not necessarily based on theorems and axioms of lines, but imagine if I had a circle. Okay, it's ugly, I know, it's ugly, and I've got a line here. I didn't say anything about it. I've got another line here. I don't know, just drawing something random. I've got a line here, and I've got a line here, and I've got a line here, such that these points lie on the circumference of the circle. A is on the circumference, B is on the circumference, C and D are on the circumference. Maybe let's say there's point T here. Okay, you've got this. And I can even draw, I don't know, I'm thinking, maybe let's say a line through here, right? Maybe to some people, line AC is a diameter. If nobody says it's a diameter, it is not. They did not tell you, don't assume. The line CT looks like a tangent. If they don't say it's touching the circle once, it is not a tangent. If they don't tell you it's a tangent, it is not a tangent. Do not assume. Do not. However, what can you say? Well, you can make the following claims. You can claim that this is a triangle. There is a triangle. You're not assuming is. You can claim the following things. You can claim them because you're looking at them. You can claim a triangle when you see one. ABC is a triangle. ACD is a triangle. I can claim that. Okay. What else can I claim? Cyclic quad. If somebody says to me A, B, C, and D are on the circumference of the circle, I can claim that that is a cyclic quad and start using the theorems and axioms of cyclic quad. Any other quad for that matter. It doesn't have to be a cyclic quad only. If I see a four-sided shape, all angles of a quad add up to 360, I can use that idea. What else can I claim? I can claim straight lines. Okay. If I see a line is straight, because it's moving straight from point A to point B, it's a straight line. I can actually make those claims and say, okay, that line is actually a straight line. So you can make those claims. Like in my diagram, I see two triangles. In my diagram, I see a cyclic quad ABCD. In my diagram, I see the straight line CT. Those things you can claim them. But if somebody doesn't say much beyond that, please do not assume anything. That will be a big problem. All right. Now, the last challenge that you guys have that I want to talk about, which is actually a misconception or errors that you generally make, involve reasons. Okay. When you guys have to provide reasons, and there are two things that I want to draw attention to. Number one, you guys provide incorrect reasons. Okay. When it comes to geometry, ignorance is not bliss. Ignorance is tragedy. Okay, so you guys have to learn your reasons very well and understand when you're providing a reason, what are you actually saying to us? It has to be correct. The last thing is in proofs. If I ask you to prove that two lines, okay, are parallel, or prove that something is a cyclic quad, you need to provide a reason at the end of your conclusion. For example, you can do something and then you're going to end up with a point where you say, therefore, for example, AB is parallel to PQ. You have to give me a reason why you're saying that. Or maybe you do another question, you say, therefore, ABCD is a cyclic quad. Okay, is a cyclic quad. I want to know why did you arrive at that conclusion. There has to be a reason. Or maybe if you say to me, triangle ABC, for example, is similar to triangle PQR. You have to give me a reason. What's your reason for making that conclusion? Because those are the last parts. Maybe it's got AAA, or all angles or the first triangle are the same as the angles in the second triangle, or you've got PPP, the sides are in equal proportions, or whatever it is. There has to be a reason when you're doing proofs. You cannot just do your proofs and not give us the reason. So that will be it. I hope this actually has opened your eyes when it comes to the challenges and errors, misconceptions that you might find in this paper. Do make sure that you understand all your work and you understand everything that is going on here before you go and write, and you don't make these mistakes. So from us, until we meet again next time, bye-bye.